This video picks up where writing equations for parallel lines left off. So the learning target for this video is I can write equations for perpendicular lines. That may not quite be the learning target for this video. We're going to investigate what's true about the slopes of perpendicular lines so that we can be able to write equations for lines that are perpendicular to each other. There's a theorem that goes along with this. I'll read through it quick, but I want these two examples to kind of help establish what's and why that theorem works as best as we can. If we were in school, again, we would be doing activities and investigations that would help us discover these truths or facts. So the theorem in blue, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now sometimes that vocabulary is a little confusing for students, so I added in here, in other words, the slopes are opposites and, forgot to underline that, reciprocals. So slopes are opposites and reciprocals, and we'll see maybe a little bit about why that has to happen. I can't expect that this is going to be perfect, but it's the best that we can do remotely. So the first thing that I did is I just drew the coordinate plane. The coordinate plane is made up of two intersecting lines, one of them vertical, one of them horizontal. And I know the theorem says that we're not supposed to be looking at vertical lines, but I think this helps kind of solidify a little bit apart about the slopes and how they're related to each other. So in the horizontal line, y equals 0, the slope of that line is 0. We rise none to get from this point to this point, and we can run 5, 4, 3, -7 if we want. So to find the slope of a horizontal line, we rise 0 and we run whatever number you want to put down here. You can put 3 if you want, you can put 7. It doesn't really matter at this point. Now I want to talk about the slope of this vertical line. We say that it's undefined. You've probably heard that. I'm going to say since at least Algebra 1, if not maybe before. So the reason why it's undefined is because of what happens when we try to do our rise over run. So if I want to get from this point to this point, I might rise 3. Let's just stick with 3. Maybe rise 3, but my run, there is no run there. I'm right in line with my point vertically, so I don't have to move to the left or the right to get from point A to point B, let's say. So I rise 3 and I run 0. Well, if we know anything about fractions, we can't have a 0 in the denominator. So the slope of the y-axis is 3 over 0. The slope of the x-axis is 0 over 3. So one thing that you might notice about those two slopes is that they are reciprocals of each other. One has a 0 on top, one has a 0 on the bottom. So I started with those two lines to give you an idea. These two lines right here are perpendicular. We know the horizontal axis and the vertical axis of the coordinate plane have to make a right angle. And from there, I just wanted to start to talk about what kind of slopes those lines have. They have slopes that are reciprocals of each other. Although it isn't acceptable to have a 0 in the denominator, so we say the slope of that vertical line is undefined. But at least this helps you see the part where the slopes are reciprocals. Okay, now, what about the opposites part? Okay, if I have two lines in the coordinate plane that are going to intersect each other and create a 90-degree angle, there's no way to do that without one of them being positive and one of them being negative. Okay, when I had my parallel lines, they both had to be going up or down, vice versa, to be parallel to each other. In this case, in order for them to intersect and create a 90-degree angle, they have to be opposites of one another. So please bear with me. I did the best that I could on the whiteboard without the grid lines to draw this out. I'm going to show you here with the protractor that we're really close to a 90-degree angle, but because I drew the grid lines by hand, it isn't quite perfect, but this equation or this line starts at 1 and it goes up to right 1, up to right 1. Okay? The blue, that's the blue line. although you can't tell very well in the video which one's blue and which one's black. This is a black line. The black line starts at -3 and it goes down 1, right 2, or up 1, left 2, because the slope is negative. And when those two lines do that, they intersect. But when they intersect, I want you to see that they are supposed to create a 90-degree angle. And I'm about maybe 3 or 4 degrees off, but again, that's because I drew my grid lines by hand, did the best I could with the materials that I had. So what I'll do is draw that out on a piece of graph paper and include that either as a file or as a picture with the video for this. So one thing now that hopefully this shows you is that the slopes of perpendicular lines in the coordinate plane need to be reciprocals first of all. Just like here I have 2, which is the same as 2/1, and this one is 1/2. And not only do they have to be reciprocals, but they have to be opposites. This has a positive slope, it's increasing from left to right. The black line has a negative slope, it's decreasing from left to right. So that brings us back to the theorem in blue. 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. In other words, slopes are going to have to be opposites and they're going to have to be reciprocals. The -1 part, watch what happens when I multiply 2 by -1/2. Those were the two slopes from the previous example that I just went through. Positive times a negative is going to be a negative. 1/2 multiplied by 2, these 2's will simplify to 1's and I'm going to be left with -1. So that will happen every time with the slopes of perpendicular lines.